Welcome in this third video about the trigonometric circle. Today we're going to have a look at how the graphs of sine and cosine can be drawn just by looking at the trigonometric circle. To do so, it is important to remember that the point here, that is corresponding to the angle alpha here from the x-axis, has an x-coordinate here equal to cosine alpha, and the y-coordinate there equal to sine alpha. So in my example here, you can see that the cosine of this angle is negative and is roughly minus 0.4, and that the sine of this angle here is positive and is roughly 0.9. So we are now ready to draw the graph of the sine function. Remember, the sine of an angle is going to be the x-coordinate of the point that represent this angle. The green point here makes an angle of 0 degree with the x-axis, here an angle of 45 degrees, and here 90 degrees, extra, etc. You have 180 degrees here, 270 there, and 360 there. Okay, so we see that when we start from 0 and we go towards 90, if you look at the y-coordinate of this point here, you see that it's only increasing until it reaches 1 when this point is at 90 degrees. So let's draw this on our graph. Starting back from 0, so when the point here is at 0, the sine is 0. When my point then gets here to an angle corresponding of 90 degrees, we see that the sine in the y-coordinate is 1. So now, in a very rough sketch, you'd be tempted to actually draw the first part of the function like this. But actually, if you look carefully at what's going on with the y-coordinate of this green point, you see that when you go to 45, so basically halfway through, the y-coordinate here is much more than half. This means that the y-coordinate increases rapidly in the beginning, and then when you get here, you see from here to there, the y-coordinate hardly changes, because you see the y difference in between here and there is hardly anything. So this means that our graph is rather a curved shape like this. And if we now have a look at what's happening between 90 and 180 degrees, we see that the exact same thing is going to happen, but backwards. Look at this point. Here the y-coordinate starts from 1 and slowly decreases and then increases more to reach a y-coordinate of 0 at this point here. So this means that the second part of the graph is going to look like this. Let's continue this little exercise. Now in between 180 and 270, you see the y-coordinate here is 0 and is going to decrease to reach minus 1 when the point is right there at 270. So this means that our curve is going to go through the point here. So we're going to get something that is like this. And finally, from 270 to 360, the point moves back up like this. So its y-coordinate starts from minus 1 to finish at 0 after one complete turn. That is to say 360 degrees, and the curve can be finished like that. And this way, we've obtained the graph of the sine function in between 0 and 360 degrees. You can notice that if this point here after rotation 360 actually continues and makes several turns, the same pattern is going to repeat, meaning that this graph can be extended to the right like this, and to the left like that. So we're done with the graph of sine. Some of the important features is the fact that it repeats every 360, and that the values of the sine are between 1 and minus 1 for any angle. I hope you feel a bit more comfortable now, and we're going to speed up things a little bit to have a look at the graph of the cosine function. So let's start again from the point corresponding to 0. You see that now the cosine of this point is interesting us, so we need to read the x-coordinate of the point. So we are going to start from 1, because the x-coordinate of this point here is 1. And if we make the green point move here towards 90 degrees, we see that its x-coordinate is going to reach 0, as the green point here moves like that. So on the graph, through 90 degrees here, you see that the graph goes through 0. If this point continues to turn around the circle, when you reach 180 degrees, right here, you see that the x-coordinate is going to be -1, meaning that our graph is now going to go through the point with coordinates 180 and -1, right there. In the next quarter turn, the point is going to move like this, so the x-coordinate is going to go from -1 to 0 now. So we can add 1 point at 270, 0. And finally, as this point here returns back to a starting point through 360 degrees, you see that now its x-coordinate is 1. So the cosine of 360 degrees is going to be 1. We then get the same kind of curve as before, here, that can also be extended to the right of this curve, and also to its left. We've obtained a graph that is very similar to the graph of the sine. It's only shifted sideways. It still repeats every 360 degrees, and the maximum and minimum values are 1 and -1. This is the end of this third video on the trigonometric circle. In a fourth one, we will review a little bit why it was so important to consider sine and cosines of angle that go beyond 90 degrees and how it's applied to our syllabus.